to record on cloud going to be easy for me. And then let's continue our discussion on hashing. And I think we covered Java hashing example. That a simple one we already done. And the collision has I mentioned the collision? This part. Do you recall? I don't remember if I have ever covered the collision. Have I ever mentioned regarding collision?
I think we finished all this PowerPoint. Is right?
Oh, this one. So the open addressing, separate chaining. So we already discussed. Is it the opening addressing linear?
I don't believe so.
Oh,
Neither.
Okay. So the collision hasn't discussed. Is it? Okay, and then let's just go over the discussion about collision. Okay, and we discussed hashing. Is it a hash table concept? Is we find the hash code of the objects. So any key, is it? So generally speaking, is you find the hash code on some key, is it key? And you can then find the hash code. Find the hash code, then we do the module operation. Is it do the module operation? Do the module operation is to find the index. You are going to place the complete, generally speaking, it's a complete record. Is it like in the book case? It's not just the ID, it's also the name. And maybe you have more like author, published date, something, is it? So more stuff, is it? And then you do the module operation, then you find the index for the record. But previously, I don't recall if the last example also show, oh yeah, the last example for that book example, it did show like for this book and this book, these two books, is it, they are hashing and their module, you will get the same result, 0, is it? And if over here, because we use array list, then we don't need to worry, is it? If it's not array list, here suppose it's just a book, you just have an array of book, then there is a problem. You can store this book here, but then for this one, it's conflict, is it? So over here, then we say we have the collision, because the second book, the result for the index is 0, but that spot is already occupied by the first book, is it? So then for the second book, where do we put? Is it regarding the hashing? The hashing concept is to quickly access, is it? And with the hash and the module, you can quickly locate it. But here, then, how do we handle this? Because there is a collision, is it? So there are a couple of ways, okay, to handle that. So that's what's the next one. So generally speaking, the techniques to handle collision, one is called open addressing. Open addressing, it says the elements of the array going to store the value of the key value pair. Okay, so that's what we have. So kind of like you have the index. So this is for index, array index, and then the array. So here is array. So array of some type. is it? Then you can only allow single item of the type. Is it be stored? Okay, be stored. And the other way is called separate chaining. The one we just showed the previous slide using array list, that belongs to this separate chaining. Okay, separate chaining, then the idea is you have the index like 0, 1, is it? And over here, then you use some linked data structure. Okay, so in our case, we have the book 1 and then book 2 as it be stored. And it's also array. Is it? It's array here. So each one of it is an array of some linked ADT, linked data structure. Okay, then we can see in that book cases, you just add the second, add the third, as that if the index conflict. But then if you just use array, how are we going to handle it? For the open addressing, is that how do we handle? So there are a couple of approaches here. So for open addressing, it says we can do like linear probing or quadratic probing, or we call it double hashing. Okay, so what does that mean? Linear probing is, so the idea is you have 0, 1, is it something to n minus 1? So over here it's index. And then over here it's book. So it's an array of some type, suppose books. Is it books? So here we have that book 1. Is it book 1 is this index. And the book 2, when you do the module 8, the index also go to 0. But you cannot, because this slot is already occupied. Is it? So for linear probing, then what it's going to do, it will try the next available after index 1. So okay, then we can try index 1. If index 1 is available, if it is available, is it? Then you can get book 2. So you just find the next available. So each time, so you try with I plus 1, I plus 2, I plus 3, something like that. Okay, you keep trying until you find an available one, then you store it there. Then in this case, it's not strictly you will quickly locate it. As if when we want to do lookup, then with just the hashing, then module, you cannot guarantee, you cannot be guaranteed you will find it right away. Is it? If not, then you need to go to the next available ones to check where it is. Is it? So it's not going to be strictly order of the constant lookup, is it? Because you may look more, is it? And if there are a lot more going to be indexed, has the same index, then you will have more available. You need more available free slots to store them. Is it? Store them, then regarding lookup, then it's not going to be order of the constant. Then it's maybe close to linear something. Is it? So this is called linear probing. Okay, and then the second way, for linear probing, its disadvantage is it can lead to exhaustive lookup. We already see this. If you have a lot clustered together, because that may be possible. Another disadvantage is the values may tend to cluster together in certain clusters. And if that's the case, then it involves exhaustive lookup. Okay, so that's the disadvantage. And then how about the second one? Second one is called quadratic probing. Okay, quadratic says it can overcome the clustering issue. And because it's not going to use the next slot, but it's going to use the 2 to the power, and the 2 to the power start at 1. So it's going to be 1 or 4 or 9 or 16 or 25 offset the original. We should see the first one. Is it the first one with the same index, with the same calculated index? Is it so offset? So then, because of its 2 to the power, is it 2 to the power? So it will not be crumpled together, clustering together. So it will distance away. Is it? But distance away, then just think about the disadvantage is what? You may run out of a slot. Is it? You may run out of slot. So that's also, it also has its disadvantage. Okay, disadvantage. Okay, and then the third approach is called double hashing. Okay, for the double hashing, then it uses a secondary hashing function. F prime, we can call it. Okay, besides the primary hashing function. So primary hashing function, we define something like this using module. So this is one approach. Okay, and then a lot of time the secondary hashing function, then you can define it, you use some constant to minus the module. Okay, then this can serve as a secondary hashing. And then you find the offset. So with this, you find the offset. Okay, the offset. And then it says the index will be treated as using like J and then, I, that's the original index, then J times the secondary hashing functions result. And the J can be 0, 1, 2, 3 as usual. Okay, so this is called, we use double hashing. And then for the chained one, it's pretty straightforward, as we already saw it. And then next, let's go to our coding. And also, I don't remember, has I already covered this example, the hash table one?
I think no. Last class we talking hashing EX.
Oh, just that very simple one, is it?
Yes. Yes.
Okay, not this one. Okay, good. Okay, and for this one, okay, then first we needed to hash table, that interface. Okay, so last time we haven't discussed this interface, Java hash table interface, is it? So over here, I'm trying to kind of mimic Java official libraries, okay? Definition for the hash set, hash map, okay, how everything comes from. Then later on, when you read the source code, you can, it makes more sense, okay? So for this, while we first design a hash table, Okay, we call it Java hash table, and it has key value pair. Okay, this is a generic one, so it's an interface. And for this interface, we have 3 abstract methods. One is called insert, key value pair, okay, and the return type is Boolean. The second is lookup based on the key, and the remove is also based on the key. And the return type is something it's called entry, okay, entry. So this entry, it holds the key value pair, holds the key value pair. That's what the entry is, okay. And then within this interface, what that entry is that, so that entry is a class that we define. So it has 2 parts, the key part and the value part. Okay, and it has a constructor, so just whatever key and value, okay, you're going to initiate. It also has a method you can get, return the key. You can also get the value. Because over here it involves the key value pair, so that's why we needed something to be able to retrieve it. And we also provide a toString method, okay, and it will give the output of the corresponding key value. Okay, so anyway, so this is a very simple interface. And then let's see this hash table, okay. So then I define a hash table. The hash table is going to implement that hash table interface, okay. And we also define the capacity, okay, capacity. And for this hash table, what we are going to implement is we using an array. And the array name, we call it buckets, okay. And the type is what? Is a linked list, okay, linked list. And the linked list type is what? Is our entry. So the key value pair, okay, from that hash table interface. So, so basically over here, what we use for this hash table, we use the chained, okay, the separate chained. We didn't use the open addressing one, okay, to solve the collision, okay. So to solve the collision, so we use linked data structure. Over here, we use linked list, that and array of linked list, so that we can avoid the trouble. And the linked list type, previously, if you recall, our very simple example is that we also have an array, and that array type is what? Is a book. Is it array type? Is a book, okay. And over here, the array type is linked list. So you have one, and you have the second array element is you have a bond, but within it, you have linked list, is a linked list. And the linked list, what the type is the entry. So each of the node of the linked list type is what? Is the entry. And the entry is what? It's the key and the value, okay, because it has 2 parts, okay, key part and value part. That's why we need to define this entry. Okay, so this is the general structure, okay, of our hash table. And for the constructor, then you just initialize its capacity. And because the buckets is an array of linked list, so that's why you need to call new linked list. Okay, and this new is for what? Is for array. Okay, because it's for array, not for linked list. Okay. And then next, let's see, how do we do, because this hash table, this hash table implements our Java hash table interface. Is it over there? We have insert, and we have what? Remove. Is it? And we also have lookup. Is it? So then this concrete class, you need to implement all of those methods. Okay. So let's start with insert first. Okay, so for the insert, so you're going to have key value pair that you insert. So the very first thing we needed to do is calculate the location where you're going, which element you're going to insert. So that's because we are going to use key for the index calculate. So you find the key's hash code. Is it? And the key can be name, is it? Can be, and in our book case, we consider the complete book, or you can use ID as key, is it? And for the index, then you need to module the array's capacity, is it? So you can find the index. Okay, once you find the index, if that specific array element is null, that means there is nothing there yet in that element. Is it? So that's why you need to create a linked list. Okay, because each array element store linked list, so you need to call new linked list. So this new is for linked list reference. Okay, it's not for array. Okay. Okay, then, and what next after you find the index? And because over here is key, we need to do a lookup. Is it? Because we want to know if the item is already there. Is it? And if the item here is a key, is it? If it finds it, is it? So that means it's not null. Is it? It's already exist in the hash table. If it's in the hash table, then that means, do you want to update? Is it? So you can get the item. So this means existing already. And if it is already, if it's not the value, then you can update. So here we update with new value. With new value. Okay. Otherwise, okay. And if the value is not, if the value is the existing value, is it? So that's what the else, is it? If the value is the same, then you don't need to do any insert. That's why it returns false. Okay, so that's what insert does. Only if it's you have update, then you update. Otherwise, you don't do anything. Okay, and that's the case if the key and the value, if the item is already in the hash table, is it? And if it is not, what you are going to do? You are going to add that entry, is it, to the corresponding linked list. This is what? This is the linked list. Linked list, is it? Then you're going to add at the back of the linked list. But with what? You need to create new entry. with the new key value pair because the key value doesn't exist in the hash table yet, is it? So you first need to create that entry and then you add to the back of the linked list, okay? So that's what this insert does, okay? Okay, and then for lookup, is it? So what lookup returns is that entry, okay, the entry, and it's based on what? Based on key, okay, key. And how do we get the entry? So you first need to calculate the index, is it, with the hash code module, the capacity, is it? And if it is not, that means it doesn't exist, as it doesn't exist in the hash table. And if it is not null, as that means it's exist in the hash table, is it? But in the hash table, you cannot just give that index location, is it, the bucket, because this is a linked list. And if it's a linked list, it may have more than one item. And if it has more than one item, you need to find which one it is. Is it? So the key, is it? Which key matches the key you are looking for? Is it? Because over here, it just means their hash code has a certain relationship. It doesn't mean the key exactly the same. So you still want to look for that exactly the same key, is it? So here we use for each loop, is it? Then do the check, one by one check. So basically here you can see it's linear, is it? It's linear, okay. So if majority of the item needed to be done this, then that's why we said the lookup, the worst case is linear, is it? Okay, so if you find it, then you can return this entry. The type is entry, is it? Otherwise, then if you complete the loop, you cannot find it. That means it doesn't exist. You return null, okay? So this is what lookup does. And then next, let's see the remove, okay? And remove has a lot of similarity between lookup because first you need to find it. So that's why first you need to find the index, okay? Still using hash code module, the capacity. Then you need to do one by one comparison for the corresponding linked list, is it? And once you find it, you just call remove, is it? Remove it, because the linked list has support the remove method, so you can directly go ahead do it. Okay, so that part is also straightforward. And then for the toString, okay, for the toString, what we are going to do is the complete hash table. Is it complete hash table? And over here for each array element, so it's going to be a linked list. Is it? Each array is going to be a linked item. Is it? So we're going to use this for each loop through the array. So buckets is array, and the E type is what is a linked list. This is our E. Is it? Then for each of it, we are just going to do what? We are just going to keep getting whatever within the linked list. So it will get the complete linked list, is it? And so we are going to output each linked list in one line. Okay, in one line. And then we return. All of this is going to be a complete string and return it. Okay, so this is toString. And then next, let's take a look the driver part. Okay, for the driver part, So this part is similar as what we learned yesterday, is that you just create an array of 8 books, is it? Array of 8 books. And then for our hash table, we don't want to cause like some book doesn't have place to store. So we also use a capacity as 8, okay? And for our hash table, we change a little bit, okay? So this is key. So book is key, and the value is, suppose it's a price. Okay, we want to get, okay, the book as key and the price as a value. And this is going to be our hash table, okay? And then after that, we're just going to call hash tables insert. Is it insert each book and the related price. So we get off the book inserted into our hash table. After that, we can try our lookup. Okay, we look up this book 211, and this is some book, is it? And we will see if we can find the book's price. Okay, and we can also do the remove. We can also specify some book you want to remove, is it? And we can also find its price. Let's double check, okay, the hash table. That hash table, yes. So the hash table, the lookup return what? Return the entry, is it? And the remove also return entry, is it? So here for the entry, then it's going to be what? It's going to be book and the price. Is it book and the price? So we should be able to get both part of the information, okay? And then let's get back to the driver, is it? So we did call the insert and do the lookup, do the remove, okay? And we can run this program to take a quick look. Okay, so here is this example's running result, is it? What do we do? Okay, this one is a lookup, is it? So the lookup does return you the book and the price. And then we are going to remove some other book, is it? That's the book, and it's the price. We get it, is it? So that's a lookup and remove. And this last part is we output the hash table, is it? So this is a complete hash table. Is it? Because it called the hash tables toString method. toString method. And you can clearly see the result, is it? For each of it, it's a linked list, is it? And some they may not have, because you remove, this is empty, that because we remove this book, is it 111, and B, this book you remove, but the linked list still exists, is it? But you can see some other hash table entry, it's null, is it? That because we never get to use it, is it? Yeah. And some just has some single book and it's a price, okay. So anyway, so this is a pretty simple hash table, okay. And what next one? Hold on. The next one is a we are going to discuss. Hold on, okay, let me remove some of this so that I won't get confused. Hash table, okay. What the next one we are going to do is we are going to see hash table. So we are going to try to mimic Java official hash map, okay. hash map. And over here, we are going to do linear probing. And after class, if you want, you can try with quadratic probing or the, oh, how can I just
open address?
Yeah. Yeah, open addressing. No, within open addressing, we, in my example, I use linear probing. Okay, and we also have quadratic probing. How can I forget the third one? It's called some hash. Use a secondary hash method. If you recall, but we didn't try with quadratic probing, and that third one, the secondary hash method. Okay, so in this example, we use linear probing. Okay, but after class, you can try with the other two to see how it works. And this time, when we testing our hash map, the reference object is a little bit complicated. Okay, we define a player class, and the player is some baseball player. We get some data from baseball league, and it has name, team, and the position, and the height, weight, and the age. So quite a lot of information, okay, regarding the player. And the player class is pretty straightforward. It has constructor, set method, get method, and also clone and toString, and the equals, and the hash code, okay, hash code. And also over here, okay, remember yesterday I also mentioned after we learn hash code, is that each time when you override equals, you need to make it also consistent with your hash code. Okay, so that's why over here we also check each individual. Then we also need to make sure the hash code, okay, both object hash code are the same. Okay. So anyway, so this is our player class, not a big deal. So let's take a look at the hash map. Okay, so for this hash map, we first define a hash map interface. Okay, this hash map interface, it has a number of methods. So we have contains key to check if certain key exists, and a certain value exists. You can also get from the key, you can get the value. Okay, so this get method is from key to return value. Okay, and the put is equal to our insert. You're going to insert a key value pair. You're also going to remove some key. Okay, it will return the value. You can also specify the key value and remove. That will return Boolean. Okay. And the replace is you replace with a certain key value with the old value and replace with new value. Okay, new value. So that's those methods. Let's see. And we also want to collect all of the entries, and we are going to store it in a set. Okay, in a set. And the set type is what? Is entry. And here we use Java officials, Java collections set. Okay. And for all of our key, we also want to know all of the keys. So we also store them in a set. So basically over here for both of these two, we will consider the duplicate as a single one, okay, because we use set. And for all of the values, we also want to collect them, is it? And we store them in some collection. Okay, so the type is collection. And then we, for this hash map, we also have the size, empty, and the clear method. Okay, so all of those are the methods, is it? And you can also see some of them kind of also similar as collection. Okay, library. But who still remembers? Who still remembers? If you recall, in Java collection, is it? We have the collection hierarchy. It's from iterable, and within under it, we have different interface. Is it like a list, queue, is it, and set? Is map also under it? Who still remembers?
No.
Yes, map is not under map, it's independent. Okay, so be careful for Java collection. Okay, and similar, the entry concept we already understand is from the hash table, is that because over here we needed to deal with key values, so that's why we define this entry. Okay, so and I don't think the entry has anything new. Okay, it's similar. Then let's take a look at our hash map. Okay, so for our hash map, okay, then it implements that hash map interface. Okay, and we have capacity as instance variable. We also want to keep track of how many items in this hash map. So that's why we add this size instance variable. Okay, and for its internal data structure, we use array. Is it? And the array type, it's entry. This type's not like our hash table. Is it? This is just an array, and the array type is the entry. Okay, it's an entry. So that's why we see over here we are going to implement with linear probing. Okay, so there is no linked data structure associated with this array anymore. Okay, the array type is entry. Okay. Okay, and then let's see. For the constructors, it's pretty straightforward. It's you just get the capacity, it's empty size. And for the array, we create what? We call the table type. The array type is entries, and so that's why you need to do that new entry with whatever the capacity is it with that. And we also cast it. Okay, so this is regarding default. No, not default. This is a constructor for our hash map. And over here, we also provide our hash method. So the hash is going to be based on key, as it is on key. And so we call the keys a hash code and then module capacity. Okay, module capacity. And you may ask, what is this? Okay, and this is some 32 bits. Looks like this. Okay, so only the most significant bit is 0. All of the others are ones. Okay, this bit, we call it a sign bit. Sign bit, okay. And what we want to do is the hash, and we end with this 32 bits, then we can guarantee a positive integer. Okay, so that's our purpose here, okay. So we want a positive integer, okay, because we want to know the index. Is it? We are going to use it for array index. We don't want it to be a negative value, okay. So that's how we get it. So that's the purpose for this hash, okay. And how do we find if it contains a certain key? Then we need to use that get to check. Okay, later on we will see that get method. And also for this value, if it contains a certain value. How do we do it? So this is array. So we use for each loop to loop through the array, is it? And if it's not null, that means it has some items, is it? Then you can call, because this is what? This is the entry, is it? This is the entry. And then you can call entries get value part. Is it? The entry has key part, value part. You call its get value, then you check if it is that value. If both are equal, then you return true. Then you can make sure if it has that value. Okay, so that's what this contain values check. And then let's see that get method, is it to find if certain key exists. If it exists, you will have the value returned, okay? So we first need to find the index. How to find the index? We call that a hash method. So this will guarantee give you a positive number, is it? And then you're going to see if it is null. Is it? If it's null, then that means it doesn't exist. And if it exists, be careful here, okay? And here it's not unique when you have that index, is it? When you do hashing, okay? So this may already occupy, is it? So like some sub I, is it? And we do linear probing. So linear probing, then we will do I plus J. Is it? J is from 0, then 1, then 2, is it? So you're going to, so this is J0. So then you need to I plus 1 to check if it has the item you're looking for. If it's not, you're going to move I plus 2, then I plus 3 plus, is it? So you're going to do all of that, okay? And normally we continue, because this I may start somewhere in the middle. And maybe when you do that linear probing, maybe you insert somewhere before I. That's also possible, is it? So that's why you loop through, go from 0 to capacity minus 1. You want to try out with all of the array elements, is it? But when you find the index, then you need to do the module. This is kind of like if you recall the circular array concept. But this has nothing to do with circular array, okay? But it's kind of that concept. So that's why, because you cannot avoid that item may also exist before I, is it that index. So that's why here you do module capacity, is it? You can guarantee it's somewhere in your array, is it? Then you can find the key, get the key, is it? And check if it's the key you are looking for, is it? And if it is, then you return the corresponding item, is it? The value part. That's what this get. Okay, basically this is our lookup, is it? Lookup. Okay, so that's the get method. And then next, let's see the put. So the put is what? Is the insert. Okay, is the insert. And here we are going to do linear probing for key collision, is it? And it says if newly added key value pair, then we return a null, is it? If key exists, then you return old value, okay? So that's what the return type here mean, okay? So still the same. You still need to do lookup, find the hash, find the index, is it? So if it's null, that means you need to create the entry, is it? The key value pair. And then you need to increment your hash map that array location, that size, that the item size, the map number of items size. And we return null, that's based on the definition. Otherwise, if it is not null, that means it's already exists. The index already occupied. Index position occupied. Is it? If occupied, then you need to look for I plus 1, I plus 2. Is it the remaining to see if they are available? Okay. So that's what we are going to do next. Is it? So you are going to loop through from the index, and then for the whole array, is it? You're going to do one by one check. Is it? Okay, and you do the module to find the location. Is it? So if it is not null, that means it already exists. Is it? That spot already occupied. Already occupied, then you need to see if the key is the same. If the key is the same, that means the key value pair already in the map. Then maybe you want to update, okay? And then you can update with the new value, okay, with the new value. And if key doesn't exist, is it so? That means the specific slot, that array slot not occupied. Is it? If it is not occupied, then you can add, you can drop that item to this new slot. Is it to this new? And you increment the size. Okay, and over here, this is not necessary. Okay, just try to do some overlap checking. Okay, so because in our data set we have some overlapped data. Okay, so this is for insert. Okay, and then for remove. So remove, you can just remove based on key, then you return the item, is it? And then here we can call the contain key to check, is it? And find the index, is it? And of course, here you need to do the module, is it? To check maybe the item insert before the index, is it? And then find the key, and then find the item, is it? And once you find the item, you can return it. But here it's remove. How are we going to remove the array? We can not remove array, clear array. So what you can do is you can reset it to null. Okay, and of course you need to decrement the map's size. Okay, so that's regarding remove. And the other remove is you're going to remove the complete key value pair, is it? So then in this case, you not just guarantee key is the same, you also need to guarantee the value is the same. If both meet, then you are going to set it as null, okay? Otherwise, if value not the same, you're not going to do remove. Okay, so then you just set your remove operation is wrong, okay? Okay, so that's regarding the remove. And then the replace. So the replace, you find the key value pair and replace the old value with the new value, etc. So similar, if the key exists, then you go ahead and do the following. Find the index, find its location, and make sure key is same, value is the same, etc. And then you can just do what? You can just update the corresponding entry is it with this new key value pair. Okay, and we cannot just directly update the value because for our entry, I didn't provide that method. Okay, so that's why here you need to just create a new entry, this new entry with the key, but is new value. Okay, and then you assign to it. Okay. Okay, so this is the replace. Then to get all of the entry set, that's set. And you over here, I use the hash set. Okay, and the hash set type is entry, is it? And then you just loop through the array, is it? And then you just add it to the set, hash set. Hash set has a method called add. If it's duplicate copy, then it won't add, it will overwrite the previous value, is it? So it will keep the unique one, okay? So this is the entry and the key set, it's the same thing, is it? You loop through and you add with the key, is it? So the set is still a hash set. And for the value part, because it's a collection, so that's why over here I use array list. Array list anyway, it's some collection, is it? So you can just keep adding, okay? And this doesn't avoid duplicate copy, so it keep duplicate copy. Okay, so that's the value one. And then we can also provide the size empty pretty straightforward, is it? And how we clear, you just assign each element of that hash map array, as assign it to none. Okay. Okay, so this is the hash map. Hash map. Then let's take a look at the driver part. Okay, for the driver part, over here, we have a quite a big baseball player data file. Okay, so we are going to read off the data from the file. And here we use a buffer reader. And total, there are about 1,034 records. Okay, so that's why over here we create an array with 1,500. Okay, and for our hash map, so the hash map, the entry is string and the value is player. Value is player, okay. And for our hash map, the size is also 1,500 so that we can guarantee, because over here we use linear probing, okay. So that's why we want to make our array size a little bit bigger, okay. Okay, and then what we are going to do is we are going to do line by line reading of that plain text file. This is a plain text file, okay. And after each line has one player's information, then we do the split, okay. We call the split, and we over here is just do some token cleaning work, okay. Token cleaning work. Then we are going to, for each player, we have that player class, is if you recall. So we create a player object, okay, player object. And then what we did is we are going to add each player to our hash map, okay, to our hash map. And the key will be player's name. Player's name. And the value is going to be what? It's going to be player. Okay, so it's some reference type. Okay, reference type. So, and over here it says And if it is not, we also do some, here is just try to do some checking. Okay, we will find that this is some player. We have a couple of players, same name. They have the same name, okay? And this is to try to find those out, okay? Find those out. Okay, and after that, after you add all of the player to our hash map, that we can also find totally how many records, that, and we can also get their key set, that key set. So it's name set, unique name set, that we can also get the name set size, okay? And we can take a look later on. We can run our program. And then what next one after our hash map does, this has nothing with to do our hash map, okay? So we have all of the player, this player is just array, that, and over here, we create a list of the player, okay? So we convert array to list using this as a list method. So anyway, so this is a list of the player, okay? And then what over here we did is, I kind of forgot what we did. Oh, so we are going to have all of the players' name out, okay? So over here, we are going to have all of the players' name also be stored in a list, okay? And here we use this list string, is it list string? And we have stream, then we can do filtering, is it? This is functional programming. So Java's functional programming concept, okay? So you do filtering as what? If it is a not null, is it? And then what we are going to do is we try to find based on the name. Okay, based on the name. So what is the filter return? It's a string. Also some string. Then we just try to get off the name out. Okay, so then you call the map to get off the name out. After the name out, you want to also make them into some collection. So you can call the collector methods, collectors to list, okay, to group them together again. Okay, so this kind of like the concept is group by name. Okay. And so we store off the name also in a list, okay, in a list, we call it names, okay. And this name set is from our map. Our map, is it? And over here is we try to find the duplicate names. Is it? How do we do it? Over here we have these names. Is it these names? This name is what? Is a list. Is it? For list, we have the method index of and the last index of. Is it? If both not the same, that means you have some duplicate name. Okay, so then you can find it out. That's how we find out the duplicate name. Okay, and over here is try to the hash map all of the values. Is it of the values? It's a collection. Is it? If you require an array list, you can get all of the player. Is it of the player? And you can also check its size. You will find this size and the set size are not the same. Okay. Then I found out this player has the same name, duplicate. There are two Georgia Julia. Okay. So we can find out, okay, if it contains And here I said, okay, and for the hash map, is it? And you can call the get, this is key. Is it? What you will have is what? Is some player, is it? This is a player. And here I said, I'm going to replace all of this player's information with the first player's information. I'm kind of hacking, okay? So over here, it's just trying to show the hash maps replace method, and it contains key method. That contains key. And after that, you can still call the key, the get method. The get method, and you will get the player's information as information. Okay, and over here, this shows maps, hash map, quick lookup. Is it just based on the key? You can do quick lookup. Is it? And for remove, it's the same thing. You can do quick lookup. Quick lookup. It's order of one. Is it just using key? Is it? And here we also try to find some other player as a container and then retrieve the information. Is it? And we can also remove. Is it to remove it? And then we try to find if it still exists. Is it? Okay, so that's how we do with this hash map of our own version. Okay, and then we can run it to take a look. So this is a running result. A lot of intermediate results just for some testing. And over here, you can clearly see. So my example, find the linear, because over here I do linear probing. Is it? So this is the array index. We do have 284. If you recall, over here you also have 284. Is it? But the real array index is at 285. This is at 286. Is it 286? So it's not at what initially specified. Is it here? Same thing. 774 is 775. 774 is 776. Is it? It's in, so it's because it's a linear probing. So there's some offset. There's some offset here. And for the corresponding player, is it because this name and this name, is it? And after we do the hash code, and then module that to 15, the result the same 284. Is it? So you cannot store both at the same location. So that's why we do linear probing here. Okay. So here it shows linear probing. Okay, so that's my purpose, to give you so many output. Is it? And you can also see the duplicate copy here. Is it some special duplicate copy? Okay. Okay, and a lot of, you can find another duplicate copy. Okay, same name. And then you can find the total player. We have 1034. Is it? But for the hash map and hash set, they are too short of. Why? It's because the duplicate name. Is it a duplicate name? Then it's overridden. Is it? And we can also find the overlapped, those two names. Okay. And the player size, that's we already removed. Is it some duplicate copy? And here is, you can use a contain, is it, and replace with another player information, is it? And after you remove, of course, it doesn't exist anymore, is it? After you remove, it doesn't exist anymore. Okay, so So we complete this hashing